Memory versus storage. The concept of memory and storage can be easily conflated as the same concept. However, there are some distinct and important differences. Put succinctly, memory is primary memory, while storage is secondary memory. Memory refers to the location of short-term data, while storage refers to the location of data stored on a long-term basis. Memory is most often referred to as the primary storage on a computer, such as RAM. Memory is also where information is processed. It enables users to access data that is stored for a short time. The data is only stored for a short time because primary memory is volatile, meaning it isn't retained when the computer is turned off. The term storage refers to secondary memory, and is where data in a computer is kept. An example of storage is a hard drive or a hard disk drive. Storage is non-volatile, meaning the information is still there after the computer is turned off, and then back on. A running program may be in a computer's primary memory when in use for fast retrieval of information, but when that program is closed, it resides in secondary memory or storage. How much space is available in memory and storage differs as well. In general, a computer will have more storage space than memory. For example, a laptop may have 8 GB of RAM while having 250 GB of storage. The difference in space is there because a computer will not need fast access to all the information stored on it at once, so allocating approximately 8 GB of space to run programs will suffice. The terms memory and storage can be confusing because their usage today is not always consistent. For example, RAM can be referred to as primary storage, and types of secondary storage can include flash memory. To avoid confusion, it can be easier to talk about memory in terms of whether it is volatile or non-volatile, and storage in terms of whether it is primary or secondary. How does computer memory work? When a program is open, it is loaded from secondary memory to primary memory. Because there are different types of memory and storage, an example of this could be a program being moved from a solid-state drive to RAM. Because primary storage is accessed faster, the open program will be able to communicate with the computer's processor at quicker speeds. The primary memory can be accessed immediately from temporary memory slots or other storage locations. There are multiple types of memory available to a computer. It will operate differently depending on the type of primary memory used, but in general, semiconductor-based memory is most associated with memory. Semiconductor memory will be made of integrated circuits with silicon-based metal oxide semiconductor MOS transistors. Types of computer memory. In general, memory can be divided into primary and secondary memory. Moreover, there are numerous types of memory when discussing just primary memory. Some types of primary memory include the following. Cache memory. This temporary storage area, known as a cache, is more readily available to the processor than the computer's main memory source. It is also called CPU memory because it is typically integrated directly into the CPU chip or placed on a separate chip with a bus interconnect with the CPU. RAM. The term is based on the fact that any storage location can be accessed directly by the processor. Dynamic RAM. DRAM is a type of semiconductor memory that is typically used by the data or program code needed by a computer processor to function. Static RAM. SRAM retains data bits in its memory for as long as power is supplied to it. Unlike DRAM, which stores bits in cells consisting of a capacitor and a transistor, SRAM does not have to be periodically refreshed. Double data rate SDRAM. DDR-SRAM is SDRAM that can theoretically improve memory clock speed to at least 200 MHz. Double data rate 4 synchronous dynamic RAM. DDR4 RAM is a type of DRAM that has a high bandwidth interface and is the successor to its previous DDR2 and DDR3 versions. DDR4 RAM allows for lower voltage requirements and higher module density. It is coupled with higher data rate transfer speeds and allows for dual inline memory modules DIMMs up to 64 GB. Rambus Dynamic RAM. DRDRAM is a memory subsystem that promised to transfer up to 1.6 billion bytes per second. The subsystem consists of RAM, the RAM controller, the bus that connects RAM to the microprocessor, and devices in the computer that use it. Read-only memory. ROM is a type of computer storage containing non-volatile, permanent data that, normally, can only be read and not written to. ROM contains the programming that enables a computer to start up or regenerate each time it is turned on. Programmable ROM. PROM is ROM that can be modified once by a user. It enables a user to tailor a microcode program using a special machine called a PROM programmer. Erasable PROM. EPROM is programmable read-only memory PROM that can be erased and reused. Erasure is caused by shining an intense ultraviolet light through a window designed into the memory chip. Electrically erasable PROM. EEPROM is a user-modifiable ROM that can be erased and reprogrammed repeatedly through the application of higher than normal electrical voltage. Unlike EPROM chips, EEPROMs do not need to be removed from the computer to be modified. However, an EEPROM chip must be erased and reprogrammed in its entirety, not selectively. Virtual memory. A memory management technique where secondary memory can be used as if it were a part of the main memory. Virtual memory uses hardware and software to enable a computer to compensate for physical memory shortages by temporarily transferring data from RAM to disk storage.